Okay, YouTube, as we continue to evaluate for trig function values of any angle in standard position, so long as we know a point on the terminal side, one big issue is going to be whether or not a trig function has a positive or a negative value depending upon which quadrant its angle terminates in. And so one thing that we kind of want to explore in this video is the fact that using our new definition of the trig functions here, that r is non-negative. As a matter of fact, I really am tempted to write r is always positive. We say r is always positive. And so assuming that r is, we'll go ahead and do that, r is positive, then what you could see is that the value of sine would depend clearly upon the value of y, because you would have something where really y over r is really something over a positive. So that is to say that if our y value is positive on the point that's on our terminal side here, then our sine value will be positive. So that is to say that any trig functions, the angle terminates in the first quadrant, has a positive y value, or if its angle terminates in the second quadrant and has a positive y value, we're going to have positive sine values. So this little chart that you see here that we're going to piece together here, basically what it's doing is it's indicating that certain trig functions have certain positive values depending upon where they terminate. So sine is always positive if you're above the x-axis and have positive y values. You can see clearly that if r is always positive, cosine values will only be positive if x is positive. So we say cosine is positive on this side of the y-axis and negative if your angle terminates over here on the left side of the y-axis. And then last but not least, we'd say tangent, which is y over x. It's always going to be positive wherever x and y have the same signs. So what I'd like to do here is I'd like to write 4 ordered pairs on this blank set of xy coordinate grid here, on this blank xy coordinate grid underneath this occupied one. And what we're going to write here is that x and y are both positive. Here we're going to write negative x, positive y. Here negative x, negative y, and here positive x, negative y's. And so what we're going to see is something instead where I'd like to write this. But essentially what this kind of, how you'll remember it is this. ASTC, and this is the little mnemonic that I use to remember it, or at least that I've heard. All students take calculus. And basically what this stands for is the fact that all trig functions are positive in the first quadrant. Any angle that terminates up here is going to have a positive x and a positive y. So when you do your sine, which is y over r, you're going to have a positive over a positive. When you do your cosine, which is x over r, you're going to have a positive over a positive. When you do your tangent, which is y over x, you'll take a positive divided by itself as a positive. It just means that all trig functions are positive in the first quadrant if they terminate there. Now, if you have a trig function that terminates in the second quadrant, the only one that's positive is sine. Now, what I want to point out here is it says sine and cosecant because they are reciprocals. That is to say that if something's positive, its reciprocal is totally positive. So with this little mnemonic here, we're going to say that all trig functions are positive in the first quadrant. The S for students here, all students take calculus. S stands for sine is the only thing that's positive in the second quadrant. You would have a negative cosine value because of your negative x. And if you took a positive y divided by a negative x, you would also have a negative tangent value. So we would say sine is the only thing positive here. Down here where it says take, we see that tangent is the only thing that's positive in the third quadrant, tangent. And then calculus, that C kind of indicates cosine. Cosine is the only positive value down if you terminate in the fourth quadrant. That's because you have a positive x value down there. So that being said, this all students take calculus thing, it's pretty nifty when it comes to saying, well, then where does your angle have to lie? So that is to say, let's take a look at this up here. It says that, hey, did you know that I have an angle here? And we say that if the sine of that angle is less than 0, that means it's negative. And we have the cosine of that angle is less than 0, which means that it's also negative. Then we want to find the quadrant in which it lies. And so using this here, we can just say all students take calculus. We know that sine is negative. And so this cannot be anywhere where sine is positive. It can't be in the first or the second quadrant. So sine is negative where our y values are negative. And we also know that cosine is negative, and cosine is negative only out of these two quadrants in the third. So we would say that this angle right here, whatever it is, theta, it has to lie in the third quadrant. So we would say theta lies in quadrant 3. Likewise, down here we say if tangent is negative, but cosine is positive, then what angle does theta lie in? Or what quadrant does angle theta lie in? And so let's start with this. Tangent is negative. So using this, we say all students take calculus. Tangent is positive here and here. So we want tangent to be negative. So it's either got to be in the second or the third quadrant. Now moving forward, we say of those two remaining quadrants, which of these shows us a positive cosine value? And that would be in the fourth quadrant. So we can't be up here in the third quadrant. which means that our angle must terminate somewhere in the fourth quadrant. So we would say that the angle theta lies in or terminates in quadrant 4.